different things that are happening here. First off, main thing we're going to talk about in this class is projectile motion stuff. And projectile motion, you have this formula that's essentially, now I'm not going to write it in the order that you learned it, probably, but you had 1/2 times the acceleration of gravity,
Yep.
right, times t squared,
I was like, it's gonna have 1/2.
plus some initial velocity times time, plus an initial height.
What's this lesson called?
Physics.
Physics. Physics.
This is called honors physics.
It's really projectile motion for physics part. So now, what is that's going to give you your position, and this is going to give you your vertical position. So I'll throw the marker up. Okay, what is its vertical position at any time? Well, I know gravity's pulling down on it. I had an initial velocity that was probably pushing it up, although this V naught could work if I threw something down, or if I just dropped it and V naught 0. But this is what's going to work. Now, how do I measure rate of change of position? That's your velocity. The rate that position is changing is velocity. You know, I can change position slow or I can change position fast. That's as fast as I get. But that's my velocity. It's the rate of change of position. So if it's the rate of change, then guess what it is? It's the derivative of position, because that's what a derivative is. Well, how do I come up with this derivative formula? Well, 2 times 1/2 is what?
1.
1.
So I get g here, right?
Mm-hmm.
And then this would be times t.
Yep.
All right, now remember v naught t, v naught's the constant because the initial velocity, there's only one initial velocity. And so it's a constant times time. So what's the derivative of a constant times time?
V.
Just a constant, right? So it's plus v naught.
I'm still flipping through my blank page.
So velocity is the rate of change of position. And in a projectile motion problem, it just happens to be gt. Now you may have used a for acceleration there, but that's what gravity is. Gravity is an acceleration. All right. Now, what is the derivative of g times t plus v naught?
G.
G. Which is the acceleration, which happens to be the derivative of velocity, which happens to be the second derivative of position.
1. I just see so many problems.
So those 3 problems can take you a long way in projectile motion problems in physics. Now, there are going to be some formulas in there in physics that you learn, especially when it deals with problems with average velocity and so forth. So some of those formulas are easier to work if you go directly to the physics formula instead of trying to solve them all from these calculus-derived formulas. But this will get you there. So, now, there's special things to know also with physics. First off, the velocity at maximum height is what?
0.
0. The velocity at maximum height, in other words, all right, and velocity has a sign, and those signs refer to the direction. Positive velocity means it's going up. Negative velocity means the object's going down. So we have a velocity is at maximum height, or velocity at maximum height is 0. Now it could be feet per second or it could be meters per second. Do y'all know what the acceleration of gravity is if you are in the standard system? Metric system's 9.8 meters per second squared. Do you happen to know what it is in the
Imperial system doesn't matter.
imperial system? Well, it's 32 feet per second. So
9.8 fancy.
yeah. All right, so V of t, all right. Now, there's another thing. At ground level, what do you think's true at ground level?
Are we still talking about velocity?
I don't know.
It's just there.
At ground level, it's just there. That wasn't quite the answer I was looking for.
At ground level, everything is zero? 'Cause it's not.
What is zero?
Velocity?
Velocity is
Velocity's
zero.
not zero.
Acceleration?
When it hits the ground, it has a velocity. Now,
Oh, you're talking about when it hit.
Projectile
We just said it's on the
Okay.
ground.
it's zero.
We were like,
So,
everything's
if I
zero.
No, I'm not.
Acceleration.
Acceleration.
Height.
No.
Well, I mean, not at the instant of impact. Acceleration is negative 9.8 meters per second squared at the instant of impact.
So
If
y
it's going
displacement
down,
should be zero.
The position is zero. The position is zero, or the height is zero. So at ground level, S of t, or P of t, or X of t, or H of t, whatever, is zero. So anytime a question asks about ground level, you know you're dealing with the equation where S of t is equal to zero. Anytime you're talking about something at maximum height, you know you're talking about where is the velocity equal to zero. What t value allows that to happen? Because guess what? S of t is not going to equal zero. Or A of t, I'm sorry. A of t is not going to equal to zero because it's just gravity, and gravity is always
Something.
negative 9.8 meters per second squared.
32.
Yeah, it's just
Now, this is just in projectile motion. Now, if I talk about a problem where I have something moving along the x-axis at a certain rate, and its acceleration may be changing. So, let's keep going from here. Also, an object is speeding up and this is not necessarily for projectile motion, this is for all velocity, acceleration, and position. An object is speeding up if velocity and acceleration have the same sign. So, think about, when is this object slowing down? I'm sorry, when is this object speeding up?
when it comes
When
down.
it-
When it's coming down, right? This marker is speeding up as it comes down. Well, its acceleration is always negative, but the velocity is negative also.
On the way down.
So, when it's going up, what velocity is positive, right? And I can't catch. So velocity is positive, so it's slowing down because acceleration and velocity have different signs there. Are we okay with this? You good?
Yes.
All right. I'm scared.
She's got a plan.
So let's go to,
Not do it.
let's look at question 14 on that worksheet I just gave you.
A particle moves.
It says the particle moves along a line so that after t seconds, its position s of t, and they give you the equation. They say find the maximum distance from the origin. Now this is not a projectile motion problem. This is just a physics problem. Find the maximum distance from the origin over the time interval from 0 to 6. Well, what is the position of this object at time 0?
6.
All right, what was the S of t equation here?
6 plus 5t minus
Minus
t
t squared.
squared.
Okay. So, what is S of 0?
6.
6. All right, what is S of 6?
6, 12.
Be careful.
Hold up. 0.
0. All right, now you might think, oh, well, it's going to be farthest from the origin when s is 0. But what might be happening here, we start off at 6, right? And we know we end up here. But we didn't necessarily go from here straight to here. We might have gone here and then turned around and come back, right? Or we might have gone here back to here and turned around and come back. We don't know necessarily what happened. But in order for an object to be the farthest away from the origin, one of two things had to happen. It's either at the end point or it's at one of these points here. Now, how can we figure out what this point is right here? That's where position changes, or that's where we change directions, right? What happens where we change directions? Go ahead and say it, you're right.
Velocity is 0.
Where velocity is 0. So this could also be happening where the velocity is 0. So how could we figure out where velocity is 0? Well, we find v of t, right? So v of t is 5 minus 2t. We want to set that equal to 0. So 0 equals 5 minus 2t. So 2t equals 5, so t equals 5 halves. Now 5 halves is somewhere between 0 and 6, right? So let's figure out what this position is. So s of 5 halves is 6 plus 5 times 5 halves minus 5 halves squared. So 6 plus 25 halves minus 25 fourths. So this would be 24 fourths plus 50 fourths minus 25 fourths. So that's going to be 74 minus 25, which would be 49 fourths. 49 fourths is approximately 12.25. Not approximately, but it is. 12.25. So 12.25 is the farthest away from the origin that we get.
Okay, so in the beginning, why did you do S?
Of 0 and s of 6?
Yeah.
All right, it was over this interval from 0 to 6, right? Okay, so if we want to consider where we're the farthest away, I mean, if the object just did this straight back in, which it could have, because at s of 0 is at 6 and at x of 6 it was at 0. So if it had just gone straight from here back to here, then this would have been the farthest away it had been, right? So I had to test my two endpoints. My endpoints are 0 and 6. I had to figure out what my position was at those 2 points, because it's possible that those are the answers. Now, the second thing I have to do is say, well, it may not have done this. It may have done something like one of those two things. So in order to find out if it did this, we take the derivative of this and we see, oh, okay, at 5 half seconds, we did some kind of a change in direction. So it just so happens that this thing did this and then it turned and came back in here. So this happened to be at 12.25.
Okay, so if our coordinates for this, if our coordinates were different, like how the 0, 6,
Yes,
so is that an interval or a coordinate?
0, 6 is an interval.
Okay, so if the interval.
Now, that's kind of funny because this 0, 6 right here, this 0, 6 right here is a point.
Yeah.
So it's a coordinate, but the 0, 6 that they gave us at the beginning is not it's a interval.
Okay.
Yes.
So how would you know if it didn't have a change in direction? If it just,
Okay, if it didn't have a change of direction, one of two things could have happened. I might have taken the derivative and it never equaled to 0. Or I could have taken the derivative, and if this t right here had been like t equal to 42 over 3, now 42 over 3 is like 13 point something, right? Or yeah, so it's like, well, never mind, it's exactly 14. So this is 14, right? So 14 happens outside of this interval right here. So it doesn't change. So the fact that I took the derivative and got the value that was in that range right there, that's what told me. Any other question? Okay.
But where did the 42 over 3 come from?
Huh?
It was just an example.
I just made up I made up a number
Okay.
that the answer to that number was going to be outside of that range.
Okay.
I need to stop this video because it's
Too long?
going to be very long.